Hello everyone, this is Gagana working as research scholar at MIT Mysore. In this session, we shall start with the problems on moment of a force. So we shall take up the first problem, that is find the moment about the point A. So the question consists of the four forces. First one is 15 Newton, second 5 Newton, third 10 Newton and a 20 Newton forces. So we shall solve for the moment of a force. So we know that the formula to find out the moment is the force multiplied by the perpendicular distance between the point and the force. So here there are four forces. So we shall consider the summation of the moment of all the forces about point A, which is equal to, let us consider the 15 Newton force. The magnitude of the first force is 15 multiplied by the perpendicular distance between the force and the point. So here is the point and this is the force and this is the perpendicular distance between the force and the point. So what is the distance? It is given that it is 1 meter and the force is acting at a direction of anti-clockwise towards the point. So this is negative. Now let us consider a 5 Newton force and multiplied by the perpendicular distance between the force and the point. Here apply the concept of principle of transmissibility. Here is the force. If it is taken here it is 5 Newton multiplied by the perpendicular distance is this. So that is 2 meter and the direction is anti-clockwise. Next force is 10 Newton force and the point and the line of action of the force are in the same line. So the moment produced by that force is directly 0. And the last force is 20 Newton force and the distance between the point and the force is 1 meter and the direction is anti-clockwise. So total moment about the point A is minus 45 Newton meter. This can also be represented as 45 Newton meter and the direction is anti-clockwise. Now we shall take up the second problem. The problem states that find the moment of force 600 Newton about point A as shown in figure. So this is the given figure which consists of a 600 Newton force which is acting at an angle of 30 degree. So the direction of the force will going to lie in the third quadrant. So what is the first step is that we need to resolve the given force . So according to its direction, so the direction of the force will going to lie in the third quadrant. In the third quadrant, the x component is also negative and y component is also negative. So on resolving, we know that the x component is given by 600 cos 30 and the y component is given by 600 sin 30. So we need to determine the moment of the given force about this point A. So the distance between this point and A is 0.3 meters. Here it is 0.2 meters. So now we shall consider the moment of the given force about point A, which is equal to, so the magnitude of the x component is 600 cos 30 multiplied by the distance between the force and the point. Here also apply the principle of transmissibility. So this force can be taken up here. So the direction will become anti-clockwise and the perpendicular distance between the force and the point is 0.2 meters and direction is anti-clockwise. So now we shall consider the vertical component of the force. The magnitude is 600 sine 30 multiplied by, so here also apply the same principle of transmissibility. The direction becomes clockwise and the distance between the force and the point is 0.3 meters and direction is clockwise. So hence it is positive. So the value becomes 13.923. The force is given in Newton and the distance is in meter. So the unit becomes Newton meter. Now we shall take up the third problem. The problem states that find the moment of 500 Newton force about the points A, B, C and D as shown in the figure. So the figure given is that consists of a 500 Newton force which is inclined at an angle 30 degree with respect to x axis. So you need to find out the moment about the point A, B, C and D. So let us find the solution for this problem. Since the given force is an inclined force, first we need to resolve the given force. So the direction of the given force will going to lie in the second quadrant. In second quadrant, the x component is negative and y component is positive. So x component will become 500 cos 30 and y component will become 500 sin 30. So here is point A, B, C and D. So first we shall find out the moment of a force about point A. So moment about point A is given by the magnitude of the x component is 500 cos 30 multiplied by the distance between the force and the point. So here the x component of the given force and the point are in the same line. So this force will not going to produce any moment about point A. Next the y component, that is 500 sin 30 multiplied by the perpendicular distance between the force and the point. So here is the force, this will become the perpendicular distance, that is 6 meters and this will going to produce a clockwise moment about point A, therefore this is positive. So the value will become 1500 Newton meter positive, hence this is clockwise. Again we shall consider the moment of the given force about point B. So again consider the x component. The magnitude of the x component is 500 cos 30 multiplied by what is the perpendicular distance between the line of action of the force and the point. So this is the line of action of the force and here is the point. The perpendicular distance is 2 meter. And the direction is, so again use the principle of transmissibility. This will going to produce an anti-clockwise moment. Hence, it is negative. Next, we shall consider the vertical component. Magnitude is 500 sin 30 multiplied by again the line of action of the force and the point. So, what is the distance between the line of action of force and the point is 6 meter, and again the direction is positive, that is clockwise. So the value will become 633.974 Newton meter clockwise. Now we shall consider the moment about point C. So which is given by, now consider the x component of the force. The magnitude is 500 cos 30. Again the perpendicular distance between the line of action of the force and the point. So here is the force. Again use the principle of transmissibility. So if you take up the force here, this will become the perpendicular distance between the line of action of the force and the point, and the direction becomes anti-clockwise. Hence it is negative and the distance is 3 meters. Now consider the vertical component, that is 500 sin 30. Again the perpendicular distance between the line of action of the force and the point. This is the line of action of the force, this is the point. The distance will become 6 meters and the direction is clockwise. So this becomes 200.962 Newton meters and the direction is clockwise. Now we shall take up the moment about point D. Again consider the x component of the force, that is 500 cos 30 multiplied by the line of action of the force and the point. So this is the line of action of the force and this will become the perpendicular distance. So this distance is equal to 3 meters and this force will going to produce an anti-clockwise moment about that point. Now the vertical component is 500 sin 30. Again here the line of action of the force and the point are in the same line, hence this force will not going to produce any moment about point D. So the moment becomes negative and the value is 1299.038 Newton meter. Direction is anti-clockwise. Next, we shall take up the fourth problem. And the problem states that find the moment of force about the points A and B for 30 Newton as shown in the figure. So the given figure is like this. The distance between point A and B is 1.6 meter. Again, the first step is that we need to resolve the given force first, since it is an inclined one. We need to find out the moment of this 30 kilonewton force about point A as well as about point B. So to take up with, first we shall apply the principle of transmissibility, and the direction of the given force will going to lie in the first quadrant. So first we will resolve the given force, that is the direction of the given force will going to lie in the first quadrant. So in first quadrant both the components are positive, so x component will become 30 cos theta and y component will become 30 sin theta. So here the given angle at B is 45 degree and 90 degree. So this is the line of action of the force. We need to find out this angle theta. So through vertically opposite angles, if I find out this angle, I can easily get this angle. So use the concept of triangle. So the total angle of a triangle is 180 degree. So here the given angle is 90 plus 45, that this will become 135 degree. So the remaining angle is 45 degree. So this theta will become 45 degree, hence the x component is 30 cos 45 and y component is 30 sin 45. So in order to find out the moment, we need a perpendicular distance between the point and the force. So here is point A and here is point B. The distance between the point A and B is given, that is 1.6 meter. So here is the line of action of the force. So we need to find out again the distance between the force and point B. So let us take up this as x. So this will become the hypotenuse side for this angle. So this will become the adjacent side and this will become the opposite side. So if you consider a cos theta, the function of cos theta is adjacent by the hypotenuse side. So we know that now cos 45 is equal to the adjacent side is 1 meter and hypotenuse is x. So in order to find out the value of x, this will become 1 divided by cos 45, and this answer is x is equal to 1.414 meters. So now this distance becomes 1.414 meter. Now we shall find out the moment about point A first. So moment about A is equal to, again now the x component of the force and the point are in the same line, hence the moment produced by that force is directly 0. Now consider the y component. The magnitude of the y component is 30 sine 45, and the perpendicular distance between the line of action of the force and the point. So here is the point, this is the line of action of the force, this will become the perpendicular distance. The perpendicular distance now is 1.6 plus 1.414, and it is producing anti-clockwise moment about point A. Now this value becomes 63.94 kilo Newton meter anti-clockwise. Now we shall consider the moment about point B. So moment about point B can be done in two ways, since the line of action, the distance, the perpendicular distance between the line of action of the force and the point is directly given. So this can be written as 30 multiplied by 1, and it is equal to 30 kilo Newton meter, or else this can also be done in another way, that is considering the resolved forces. So about point B, again the 30 cos 45, the x component is producing a moment of 0 because the line of action of the force and the point are in the same line. Let us directly consider the y component, that is 30 sine 45, and the perpendicular distance between the line of action of the force and the point. Point is point B, so the perpendicular distance is 1.414, and it is producing again anti-clockwise moment about point A. So this will become again 30 kilonewton meter negative, that is anti-clockwise. So now we shall take up the fifth problem, which states that the moment of a certain force whose magnitude is F is 180 kilonewton meter clockwise about the point O, and 90 kilonewton meter anti-clockwise about point B. So if its moment about point A is 0, we need to determine the magnitude of the force F. So the given figure is Here is the force F. The inclination of the force with respect to x-axis is theta. The distance between the point A and O is given as 3 meter, and the distance between the point O and point B is given as 6 meter. So again, in this problem, the given force is an inclined force. First we shall resolve the given force. This is point O. So on resolving, the direction of the force will going to lie in the fourth quadrant. In the fourth quadrant, the x component is positive and y component is negative. F cos theta and y component will become F sin theta. So this is point A and this is point B. So first we shall consider what is the given data. So on writing the given data first, we will going to get the solution easily. So the moment of a certain force F, here is the force F, which is having a moment of 180 kilonewton meter clockwise about O. That means the moment about the point O is equal to 180 kilonewton meter and the direction is clockwise, and the same force is having a moment of 90 kilonewton meter anti-clockwise about point B. And what they are saying that if the moment about point A is equal to 0, we need to find out what is the magnitude of the given force F. So we shall consider the first int given, that is moment about point O is equal to 180 kilonewton meter. So the value of the moment is directly given. Now we shall consider the moment of the individual forces separately about point O. So first consider the x component of the force, that is F cos theta, and the distance between the force and the point is given that it is 3 meter. So F cos theta multiplied by the perpendicular distance between the line of action of the force and the point is 3 meter, and this force is producing a clockwise moment about O. So that is, it is positive. Again here the vertical component, that is F sin theta, and the point are in the same line. So that's why this force will not going to produce any moment. So which is equal to the moment 180. Now on solving this will become 0. F cos theta is equal to 180 divided by 3. So F cos theta is equal to 60. So that is, which is nothing but this F cos theta is the x component of the force is equal to 60 kilonewton. So using the first int, we got the value of x component of the force. Now again we shall use the second int. That is, the moment about point B is equal to 90 kilonewton meter anti-clockwise, that is negative. So the value of the moment is directly given. So we shall consider the moment of individual forces separately about point B. So first we shall consider the x component of the force, that is F cos theta, which is nothing but the Fx. So the value of Fx, F cos theta multiplied by, here is the line of action of the force and this will become the perpendicular distance. So the distance given is 3 meter. And this force is producing a clockwise moment about B. So that's why it is positive. Again we shall consider the y component, that is F sin theta. Here is the line of action of the force and this will become the perpendicular distance. So this distance is given as 6 meter and this force is producing an anti-clockwise moment, that's why it is negative, which is equal to the total moment about B, that is minus 90. So we know the value of F cos theta, which is nothing but this is Fx. So this can be considered as Fy. So F cos theta, that is Fx, the value of Fx is 60 multiplied by 3. So on solving this, Fy is equal to 180 plus 90 divided by 6. So Fy is equal to 270 divided by 6. So Fy is equal to 45 kilonewton. So we got the value of x component and the y component. So again use the concept of resolution of forces or composition of forces. So using that Fx and Fy, find out the value of the original force F. So we know that the resultant of the given forces F is equal to square root of Fx square plus Fy square. So on solving we got the value of Fx as 60 and Fy as 45. So on solving this we will going to get the value of F as 75 kilonewton. And we need to find out the direction of the given force. So for that find out the value of theta, and we know that tan theta is equal to mod of Fy by Fx. So theta is equal to the tan inverse of the value of Fy is 45 and the value of Fx is 60. So on solving this we got the value of theta as 36.87 degree. So the next problem states that determine the angle theta so that theta is greater than or equal to 0 and less than or equal to 180 degree for the force F is equal to 200 Newton, so that it produces a maximum moment about A and a minimum moment about A, and the given figure is that the distance between point A and C is 5 meters and the distance between the point B and C is 3 meter. So, in this question we have to find out the two values of theta, so that the value should be greater than or equal to 0 and should be less than or equal to 180 degree, so that which is having a magnitude of 200 Newton, that it should produce a maximum moment about A and minimum moment about A. So, we shall find out the solution for this problem. First, we shall consider the first condition, that is the force should produce a maximum moment about A. When will a force will going to produce a maximum moment? A force will going to produce a maximum moment when it is placed at a perpendicular direction towards the point. When it is placed perpendicular to the point. So, here we need to find out the maximum moment or the moment about the point A. So, for that we shall consider the given figure and join the points A to B. So, this force should be placed in such a way that it should produce a maximum moment about A. This force will going to produce a maximum moment about A when it is placed perpendicular to this point. So, I am going to place this given force at a perpendicular position about point B. Let me now consider this as an angle theta, and let me consider this angle as alpha, so that this will become 90 minus alpha. If this is 90 minus alpha, this is also equal to alpha. Now let us, in order to find out this inclination angle, first we shall find out this angle alpha. So, how to find out this angle alpha? I know this distance from point A to C and I know this distance from point B to C. Maximum moment about A the force should be placed perpendicular to the line AB. So, therefore, to find out this angle alpha or the inclination angle, I know this opposite side as well as the adjacent side for this angle, so that I can consider tan alpha. So, tan alpha is equal to 5 divided by 3. So, alpha will become tan inverse of 5 by 3. So, therefore, alpha is equal to 59.04 degree. So, I got the value of alpha now. So, now using this value of alpha, find out the value of theta. So, we know that this total angle is 180 degree. I got the value of alpha. Now, theta will be equal to 180 minus alpha, which is equal to 180 minus the value of alpha is 59.04 degree. So, theta will be equal to 120.96 degree. So now we got the inclination value of the force so that it should produce a maximum moment about A. Now we shall find out the maximum moment. So in order to find out that maximum moment, we need the perpendicular distance between the line of action of the force and the point. So now we shall find out the value of AB so that it is easy to find out the maximum moment. So in order to find out the perpendicular distance, we shall use the Pythagoras theorem. So side AB, which is the hypotenuse one, will be is equal to 5 square plus 3 square. So this will be is equal to 5.831 meters. Now therefore the maximum moment about A is the force multiplied by its perpendicular distance. So this F is equal to 200 Newton. So 200 multiplied by its perpendicular distance towards the point is 5.831. So this will constitute a value of 1166.2 Newton meter. So this is the maximum value of the moment that a force is producing about point A. So now we shall find out the value of minimum moment. So when will a force will going to produce a minimum moment? When a force is placed in line with the point, that force will going to produce a minimum moment. It may be a 0. So we know that when the point where we need to find out the moment and line of action of the force are in a same line, that force will going to produce a 0 moment about the point. So the minimum moment of force will be produced when it is placed in line with AB. That means the figure becomes again this angle is alpha, or sorry, this angle is theta, and this as a value of 5 meter and this as a value of 3 meters. So we shall find out this slope angle. On finding this slope angle, this will also become theta. So through vertically opposite angles, if this is theta, this is also theta, we will going to get this value. So how to find out this value? So in order to find out this value theta, again we shall use this distance and angle concept, that is again from triangle ABC, tan theta is equal to 3 divided by 5 and theta is equal to tan inverse of 3 by 5 and the value of theta is 30.964 degree. So, as the line of action of the force and the point are in same line, the moment produced is minimum. So, therefore, M minimum is equal to 0. Therefore, M minimum is equal to 0. So, now let us take up the next problem. So, the given problem states that determine the two values of alpha so that alpha is greater than or equal to 0 and less than or equal to 180 degree, for which the combined moment of the two forces about point A is 405 Newton meter anti-clockwise. So, the given figure is that in the given figure there are two forces. One is the 300 Newton force which is inclined at an angle alpha, and another one is a horizontal force having a magnitude 600 Newton. So, in the question it is given that you need to determine the two values of alpha so that limit should be greater than or equal to 0 degree and should be less than or equal to 180 degree. So, for which these two forces have the combined moment of 405 Newton meter anti-clockwise about this point. So, they have given the value of moment, you need to determine the inclination angle. So, how we will going to find out this inclination angles. So, and it should be a 2 value. So, one is this position which is given in the question. So, we shall find out these two orientation so that the moment produced by these two forces in both the cases are equal. So, how to find out that? So, first the two orientations of the 300 Newton force, for which the moment about A is same is as shown below. So, for that we shall again consider the given figure. So, this is the orientation given in the question. We shall consider the same thing, and at this point we have a horizontal force which is 600 Newton force, and here is the point A. Let us consider this as figure A. So, since this is an inclined one, on resolving, the x component is 300 cos alpha and y component is 300 sin alpha. And again consider the figure 2. So, now I am going to consider this same 300 Newton force along the negative x axis with the same inclination alpha . So, again on resolving, the x component will become 300 cos alpha and this is 300 sin alpha. So, observe in these two figures, the x component of both the orientations will not going to produce any moment about point A, because the line of action of this x component in both the cases are in line with point A. So, therefore, in both the cases the vertical component, that is 300 sin alpha only, and this 300 sin alpha is in positive direction and will going to produce the same moment about point A in both the cases. So, the moment by (300 Newton force) is same in both the cases, because vertical component in both the cases is positive 300 sin alpha and 300 cos alpha will not produce any moment about A. So therefore, it is given that moment about A is 405 Newton meter anti-clockwise. Now we shall consider the moment of each individual force about point A. First we shall consider this vertical component which is having a magnitude 300 sin alpha, and what is the distance or the perpendicular distance between the line of action of the force and the point. So this is the perpendicular distance. So the distance given here is 700 mm. Since the moment is given in Newton meter, I am going to convert this to the meter only. So this is 0.7 meter and another one given is 200 mm, or this can be written as 0.2 meters. So 300 sin alpha multiplied by the perpendicular distance towards point A is 0.7 meters, and this force is producing a anti-clockwise moment, so that is why it is negative. Next, the moment produced by this horizontal component is directly 0. Now consider this 600 Newton force. What is the perpendicular distance? So the distance given is 500 mm. So on converting, this is 0.5 meters. So 600 multiplied by 0.5 meters, and this will going to produce again a anti-clockwise moment about point A, which is equal to minus 405. So this minus and minus gets cancelled. So therefore, sin alpha is equal to divided by 105 divided by so alpha will become 30 degree. So this is the one value of alpha for which the moment produced by both the forces will not going to alter. So the second value of alpha will be, that is, for the second case, the angle of the 300 Newton force and the positive x-axis. So we have considered the angle alpha in the second case with respect to negative x-axis. So that angle is 30 degree only. So we need to find out the two orientations with respect to positive x-axis. So and the positive x-axis will be 180 degree minus 30 degree, which is equal to 150 degree. So therefore, alpha is equal to 30 degree or 150 degree. For both these angles, the moment produced by both the forces will not going to alter.